Hello guys, and welcome to our 8th lecture on Java programming for beginners. In today's lecture, we will be looking at constructors, we'll look at the new operator, we'll look at object instantiation, and later we will talk about object reference type variables. Now, what is a constructor? I have a message here, a sentence that says a constructor is a Java block of code similar to a method that's called when an instance of an object is created. Now that sounds like a definition with too many unclear words. For example, we say it's like a method, but it's really not a method, and we say it's an instance of an object. So what is an object? I'm sure we are all familiar with the concept of building houses. For example, if you decide to build a house today, let's say you get a piece of land and you decide you want to construct a building. What is the first thing you do? You get an architect, analyze the land, and maybe draw up a blueprint, a plan for construction of the house. Now, after this plan is drawn, you require your builders to construct your house. What do? They look at the plan, they build the house. They look at the plan, they know there's supposed to be a pillar here, there's supposed to be a wall here, there's supposed to be a window here, and they use what the architect has put on the blueprint and they construct a full house. Now, in Java, we write classes, and constructors are actually what are used to construct the actual class, the actual objects. For example, here I have a calculator class, and to construct an actual calculator in memory, we will need to call the constructor for that class. So before we get into the details of the objects, the blueprints, and the classes, let's talk about constructors. Now, a constructor is a special kind of method. I like to put it like a special kind of method, even though to me it's really not a method, but you're gonna get many people saying that, and it's going to bring out the concept of seeing it. The idea of seeing it like a method brings out the message clearly. So our definition here says a constructor is a group of statements, a block of statements similar to a method that is used to construct an instance of an object. Now, I have two classes here. There is one to the right in blue, and there is another one to my left in green. You would see that the class here, the one in green, is exactly what we have always seen before. We have our public class calculator, we have the beginning and the closing curly brace of the class, and we have the class content, the body of the class, which comprises of two methods. First, the main method, which we have said every Java program must have, and we have another method down here, public void add. Now you would see that on this other side there is something extra I have put inside here. That is public calculator. I have a set of parentheses, I have an opening curly brace and a closing curly brace. Now, that is what is referred to as a constructor. If you go back to our definition up there, you would see that the definition says it's a block of code similar to a method. Exactly, you realize that every constructor has an access modifier and a name. It has a set of curly braces too, and a set of parentheses just after the name. Same thing for our methods. Every method we have seen so far has 5 compulsory parts, which include the access modifier, the return type, the name, the set of parentheses, the opening and the closing curly brace that mark the body. That makes 5. And for receipt 1, we have an optional list of arguments that we can pass into our methods. Same with our constructor. Constructors have an access modifier, a name, a set of parentheses which can take an optional list of arguments, and you have an opening and a closing curly brace that mark the body. So you would see the only difference that we have, or one principal difference that we have between the constructor and a method, is the fact that the constructor has no return type. Now, if you have also noticed, I'm sure you would have, the constructor has exactly the same name as the class. So, if we would go back to our definition, I think it would be right for us to say a constructor is a block of statements similar to a method and has the same name as the name of the class. So we can see here our class is called calculator and our constructor is calculator. Remember, Java is case sensitive. So if it's an uppercase C here, it must be an uppercase C for the constructor. However, you would see that the class has no set of parentheses just after the name, but the constructor has a set of parentheses just after the name. And that is what you will be using to construct actual objects from your classes. Now, before we go to the next slide to talk more about constructors and the new operator that is actually used to call a constructor when we want to create a real object in memory from our class blueprints, let's go over it again. A constructor must have a constructor must have an access modifier. It has no return type. It must have a name which must be exactly the same as the name of the class. It must have a set of parentheses with an optional list of arguments. In this case, we have no arguments. Later on, we will see constructors that actually take arguments, and it has a body which is defined by the opening and the closing curly brace. So with that said, let's see how to use a constructor. Before we go to that, there's something. The constructor that we have right here is actually what is known as a default constructor. You would see this class here, the one in green. I have created the class, but there is an empty space here. I've not put any constructor in it, but when we run our program, the program is able to execute and we can call different methods in the class. Why? Because every time, if you remember earlier, I said when you create a class, it's just a blueprint, but the constructor is what you call to actually create an object from that class. So every time you write a Java class, if you don't put a constructor inside, the Java compiler will put a constructor for you. Later on, we will see that when you add another constructor that is different from the default constructor, the Java compiler will not be able to do that. We'll talk about that shortly. But for now, once you write a class that has no constructor, the Java compiler automatically inserts the default constructor. And the default constructor usually takes no arguments and it has an empty body like this. So this code that you see here in green, by the time you compile it, the Java compiler will add this portion here. It will add a constructor inside here for your class so that your class can be your objects can be properly constructed. Okay, with that said, let's see how we actually construct an object from a class. Now, if you remember when we looked at the Java keywords, there was also a keyword, the new. Now, Java is case sensitive, so you should note new is lowercase. Actually, all Java keywords are lowercase. Have that in mind. I can't remember anyone being uppercase. Alright, with that said, I have a class here, calculator, similar to the previous one. And this class has two instance variables. Well, one is a variable and one is a constant. Somebody would say, or some people would say, a constant variable. Well, when they say that, it's just to make you get the concept. But in reality, I mean, if it's a constant, then it cannot vary, so it's not a variable. So we have a variable result and we have a constant pi. Now, when you write your program, this is all what you write, and it lies somewhere on your hard disk waiting to be executed. Now, when you start running this program and you want to use an actual calculator, what's going to happen? Your compiler, let's follow let's go through, let's see how the code execution works so that we will know exactly when the constructor is called and how it builds a class. Now, initially, when we run our program, when our program is in memory, or when our program starts, it looks for a main method defined like this. The compiler, the Java virtual machine looks for a main method that looks like the one we have here, public static void main, and that's where it's going to start our program. So when our program starts executing, immediately it gets to this point, calculator C. What happens? By this statement, we are telling the compiler that reserve some memory for us to store an object of type calculator. Now, to make that clearer, I'm going to go back to our primitive data types. Remember when we talked about data types in one of our early videos, we said Java has primitive data types, which are the integer, the character, the boolean, the short, all of those that we saw. And we also said Java has object data types that we were going to talk about later. Now, this is an example of an object data type. But to explain that, let's review what happens when we declare a variable to be of a primitive data type. When we say int result, what are we telling the Java environment? We are telling the Java virtual machine, hey Java, what I want you to do is create me space in memory and call it result. When you create the space, make sure it is capable of holding an integer, any number that is the size of an integer. That's exactly what we are telling Java. Create me a space in memory, call it result, and make sure when I save in a positive or negative value with the size of an integer, it would probably fit into that space with no problem. Same thing. Now we have created an object. This class, we have actually created a class, sorry, not an object. We have created a class, calculator, and the class has two variables here. Well, one variable and a constant. It has a variable result and a constant pi. So now when we declare this, immediately you create a class like this, you have actually added a data type, what is known as an object data type, as opposed to the primitive data types. By creating this class calculator, we have created an object data type in our program, and this data type is calculator. This data type is certainly very similar to the string data type. You have seen in our previous videos, we declared a string and put the name of somebody inside, for example. So string is an object data type that holds strings. This one is a calculator data type. And what makes up this data type? We have an integer result and we have a float called pi. So now when I say calculator C, I'm declaring a variable of type calculator and I'm calling it C. So I'm telling the Java virtual machine, hey Java, please create me memory to be able to store an object of type calculator. So what the Java virtual machine is going to do is it's going to go into my memory. Now this is not supposed to be there at this point. Immediately I say this, I'm declaring a variable. So it's going to go into memory and it's going to reserve me empty space that can store an integer. So result, at this point it will declare space for result, but the result will have a 0. Yeah, fine. It has been, the result will be initialized with the value 0 because 0 is the default for an integer. Pi would be initialized because here we have declared it and initialized it at once. But it's just reserving memory that is capable of holding all of those things. It's not putting anything there yet. So when we say calculator C, we are saying, hey, Java, please reserve memory for me to be able to store an integer and a floating point number. Now, later on, like, just to repeat, after this declaration, memory is reserved, but there is nothing inside this memory location. Later on, when I say equal to new calculator, what happens? Java will actually come inside here and now put result there as 0 and put pi there as 3.14159. To repeat, when you say calculator C, you declare the variable. Space is reserved, but there is nothing inside. So at that point, this will not be there. All of this space would have been reserved for my application to use, but then it will be blank. Later on, when I say new calculator, so I'm creating an object. So Java now will come inside here and it's going to put a value, put an actual object of calculator type inside here with the result having 0 and pi having 3.1415. And in that case, we now say the object has been instantiated. We're going to talk more about this on the next slide so that we'll actually see some examples. So let's get to it. Okay. Now, before we go further to instantiate objects, like we said earlier, constructors also take in an optional set of arguments in parentheses. Constructors can also take in an optional set of arguments in parentheses, and that's what we have right here. You would see that my class has two constructors. The first one is the default constructor, public person, parentheses, nothing inside, and the body, which is also empty. This is what is known as a default constructor. If you have a class without any constructor, the Java virtual machine will the Java compiler will insert a constructor for you when compiling your program. Now, my class has a second constructor, public person. Look at the constructors all have the name of the class, but there is no return type, like we said, to differentiate them from a method. Now, the second constructor takes in two arguments, int ph and string pname. I simply put that to differentiate them from the instance variables that we created here. Later on, when we use the these reference, you will actually understand how to differentiate them, even if they have the same name. But for now, I decided to name them differently so that we can explicitly distinguish. So when I'm going to call this constructor, I'm going to pass in two values. So to construct our classes, when we want to construct our class, we want to construct a real person in memory, we can actually use any of the constructors. Like I said, classes are blueprints for creating real objects. Going back to the analogy of a house blueprint, a building plan, and the house, the plan is actually just a template that is used for creating the houses. You look at the house, you look at the plan, and you construct the house. You can look at the plan and you construct as many houses of the same design as you want. Same thing, when you run your Java program, Java looks at the classes and it constructs many objects from each class depending on the requirements of the program. So in this case, I have a class person that has two constructors, which means my persons could be constructed in two different ways, and we're going to see how that happens. So I come here. When I run this program, our program will start from the public static void main method, which is where Java starts all our programs when we run them. So here we have insert code. Here, this line that says insert code, and the code that we will be inserting here is this one that you see here in blue, this one here in blue, this one here in blue. We're going to see what happens at every given time when we do that. So what's going to happen? When I come inside here and my program starts, let's say insert code here, and the first code we insert is new person, and inside the parentheses we are passing 23 and a string Andy. What's going to happen? Here, immediately we do that, when the compiler sees this line of code, or when you're running your program and when it reaches this line of code, what's going to happen is you're calling this constructor. Look at person, and you're passing in two arguments. So the compiler looks through your class, or the Java virtual machine looks through your program, and it sees, hey, Java goes through all of these and it sees, hey, okay, I have two constructors, but this is the one being called. And how does it know that this is the one being called? Because you're passing in two values, and it's able to see that the first one is an integer and the next one is a string, and it goes and it identifies this. Later on we'll go detailedly into that when we talk about constructor overloading. That's what we're actually doing here, but I won't talk about that for now. I want you to understand the concept of constructors first, and later we'll talk about that. So here we are saying we are passing in two values. One is an integer and one is a string, and Java scans through our class and it sees there is a constructor that matches exactly that format. It takes the first value, the first parameter, an integer, and the second one a string. So it's going to call this constructor. Now when it calls this constructor, what's going to happen? It's going to take the value that is passed here. So ph will be initialized with the value 23, and when we get inside here, 23 will be passed into h, which means h will now hold a value of 23, and this h here, remember, it was declared here initially and it had a value of 0. And then after that, the next thing we do is we take p name, which will be initialized by Andy, and we pass it into name. So name, instead of having no name, it will now have the name Andy. And later on, our program is going to execute system.out.print. Name is age. It's going to print Andy is 23. How does that happen? When you say new person, what Java does is it creates a person in memory, and it initializes all the variables, all the values of that person. It initializes the variables for this class with the actual value for this person. So it's creating a person. Same thing like your plan of the house. When you're using the blueprint on one, all of them follow the same structure. All the houses on the blueprint that you construct from that blueprint will follow the same structure. But you can later on decide to paint one blue, paint another one red, make another one to have wooden windows, another one to have glass windows. Same thing with our classes. We are constructing an object from this class, this blueprint, and now we are saying the name of the object should be Andy and the age should be 23. So immediately you do new person, your constructor is called, and it actually constructs that person in memory. It builds an actual person in memory from this blueprint, looking at the template that was here. Now we go on to the next one, new person, and in parentheses we have 44 and we have rows. Now you will see that in memory, what are we going to do? When we insert the code here, what's going to happen? When we insert the code here and we run, we will actually see that the person is now rows and the name, the age is 44. Why? Because at this other point, we are creating another object. This one has already been created. If you look at the address here is different from the address here, which means this person has been created and kept in a different address. This one will also be created and kept in a different address. So when we say new person 44 and rows, we're calling this same constructor, and it's creating an object in memory and initializing the instance variables age and name with 44 and rows respectively. Look at the memory locations are different. Same thing. You have a blueprint. When you build a house, you build your house in one location. You cannot build the second house on that same spot unless you take it out. So you need to go to another place and you build the house. Same thing when you call new, Java creates an object in memory When you call it again, it goes to another portion of memory and creates another object. If he has to create the object in the same place where it created the previous object, then he has to first of all take out the previous object. Now, there's a little difference here. When I call new person, if I insert new person here and I run this program, the output will actually be no name is 0. Why? Because now I am no longer calling this constructor, right? I am now calling the constructor, the default constructor that takes no arguments. This one, I'm calling this constructor that takes no arguments. And since it does nothing, sorry, I changed the slide without knowing. Since it does nothing, what's going to happen is the values, the instance variables of this class will take up the original values they were initialized with. Originally, we initialized them with 0 and no name. So when we run this code, what we will actually have in memory, Java will come in memory and it will put 0, which is this value for age, and no name for the name. Later on, we will see how you can actually call a different method, which will be this one here, to actually change those values. But to do that, you will need to store this address somewhere so that you'll be able to use it. We'll talk about that shortly. Now, before I continue, I'd like you to note one thing. This here, I have two constructors. Why? I would have left this. This is the default constructor. It's doing nothing. So why did I have to put it? Now, once you put a no argument constructor into your class, Java no longer inserts the default constructor for you. So if I don't have this, and if I don't explicitly put this after adding this one, then I cannot do this. I can only do this without any constructor or with this one alone. But once you have a constructor in your class that takes in arguments, Java no longer inserts the default constructor for you. And if you will be needing a default constructor, then you will have to create it yourself. Okay, with that said, I hope we get it. Now let's talk about object reference variables, and we will talk more on initialization here too. I have the same class, but this time, before initializing the variable, like we create an object, but then we don't just put it in memory. After we keep it in memory, we store the address into a variable. So same like we have been seeing before, like we saw with the calculator class. Here I'm declaring a variable of type person. Like I said, since I have a class person in my program, I have created a new data type for my program, and that data type is person. So I declare a new variable of type person and I call it P1. And what I'm saying by this statement is, hey Java, please reserve me some space to be able to store a person. And Java keeps the space with nothing inside. Now when I say new person and I pass in 23 and Andy, what happens? Java goes into memory, the memory location that it kept for me, and it creates a person. It creates a person there with the age 23 and the name Andy, and it stores the address into the variable P1. You will see here P1 is equal to this. So it's storing this address into this variable, because later on I might want to use that person, and if I don't have a way to get to it, then it will be lost in memory somewhere. Your memory, computer memory, is too big. If somebody told you I constructed a house somewhere on earth, that would certainly not make any sense for you, I guess. It will make more sense if the person said I constructed a house maybe in the United States, in South Africa, anywhere, in Cameroon, anywhere, and give you the precise address of where that house was constructed. In that case, when you want to go get something from the house, or you want to show it to somebody, or you want to explain something to somebody there, you know exactly where to go get it. Same thing with our Java programs. When you write a Java program, what happens is, when you write a Java program and you create your objects like this, those are the blueprints. Your classes, those are the blueprints. When you create an actual object from that blueprint, it has to be created somewhere in memory, and you need to keep the address if you want to get back to that portion of memory and use the object that was created. So what we are doing here is we're creating a person in memory, and we are storing the address in a variable p1. Later on we can use it to do something else. So here I say person p1 is equal to new person, and in parentheses I pass 23 and Andy. It goes to memory and it creates the person, and then it stores the address, here is 11001, into this variable. Same thing with this one. Now I say person p2 is equal to new person. This time I'm calling the constructor, the default constructor that actually does nothing except create the object. The job of this constructor is just to create the object, and it creates the object with the default values that we have here at instantiation, when we instantiated and initialized the variables at the same time. So we have age as 0 and name as no name, and the address of this location where that object was created is stored inside the variable p2. Now later on we can come back and change the value of p2, like change the contents of the object, like modify the object p2. How do we do that? Remember, here we kept the address, the location of p2, so we can comfortably go there and change it. And how are we going to do that? Inside our class here we have another method, public void set person data, and we are passing ph and pname. This is not correct. We need to specify the data types of the variables. Actually, I was running out of space and I squeezed it all inside here. I'll do that in the practical part and we will see that better. So I say age is equal to ph and name is equal to pname. And what happens? Here, when I call my method, here I say p2. p2 is an object reference of type person. It's a person that was stored in this area p2, so it definitely has this method and these variables. So what's going to happen here is it's going to pass this value into ph and this scattering into pname, and it's going to initialize the variables, and at that point these values inside that memory location will be changed. Now, before we proceed, I just want to remind you of the fact that you should always remember that once you have a constructor that takes in arguments, the compiler no longer puts in the default constructor for you. So with that said, we are going to go now and write some code to actually see what we have been talking about. But before we do the code writing, I have some rules here that I think you should always have in mind when you talk about classes and constructors. The first one is the constructor must always have the same name as the class name. A constructor will have no return type. That's the second. The next, the compiler will generate. The compiler generates a default constructor if you don't have any constructor. The compiler won't generate a default constructor if you already have one with arguments. Be careful with those two. The compiler will generate a constructor for you if you don't have any constructor in your class. But if you already put in a constructor, then the compiler uses your constructors and it no longer gives you the default constructor. So if you have a constructor with arguments and you still want the constructor, the default constructor without arguments, you must write the two in your class. And lastly, the constructor has the same access modifier as the class. In this case, all our constructors have been public, and they will continue being public till we talk about access modifiers later on. So with that said, let's actually put all of these into practice and see exactly how it works. So I'm going to bring up my NetBeans IDE, and I'm going to create a class here, person. I'm just going to go new class. I'll right click on my project and I take new class, and I'll call it person, and I finish. Now I'll go into my person class, and I'm going to put in some methods. Public void print person, system.out, or let me say public void set person data, and I'll leave it there for now. I'll create some variables for the person. Int age, it's going to be empty by default. String name, I'll leave it empty by default, so it's going to take default of 0 for the int and a default of null for the name. And down here I would just say, okay, I'll pass in some parameters into these that will be used to set the name of the person and the age. Int page and string pname, like we had on our slides. And down here in the body I would say age is equal to ph, and name is equal to pname. Remember, Java is case sensitive. I'll add one last method inside our person class, the method that will actually print the person. Public void print person, and I would say, sorry about that, system.out.println, println. We'll look at that later on and see what it actually does, but for now let's just know it prints a string that we pass in onto the console. And here what I'll do is I would say name plus a string is age years old. Okay, we're good to go. I need a concatenation operator here. Now that's my person class that has been created. I'm going to go back into our original Java class, the one that has the main function, and I will wipe off all what I have inside so we can have some clean space to work with. And okay, I'll save it. Now if I run this program, nothing is going to happen, because remember, Java programs start executing from the main method. So when it starts here, it's going to execute the code inside here, and the program will stop execution immediately it hits this closing curly brace of the main method. Now if I run the program, I will not have anything because I don't have any code inside that main method. You would see my output is blank, nothing. So what am I going to do here? I'm just going to put some statements. System.out.println, and I say main method started, and down here I would say system.out.println. I'm going to leave that so that it just prints an empty line, and then I'm going to print the last thing, system.out.println, and I'll say main main method ended. Now when I run this, I would see those two lines: main method started, some space, main method ended. Okay, that is done. Now let's go back to our person class. What do we have inside here? Our person class has two instance variables and two methods. But then, how do we access this? To be able to, how do we create an actual person in memory? We need to create an actual person in memory, and to do that, we do that by using new person. There we are calling the constructor. But in this case, when we call the constructor, it's just going to create the person, and the person is going to get lost in memory. So we really can't use the person to do any other thing. So to be able to use that person, we will store it in a variable. So I will create a variable of type person, and I'll call it P1, and I will store the object that we create. So when we run this piece of code, it's going to create a person object, and it's going to store the person object inside this variable P. Well, it's actually going to store the address to where that object is located, and we can use that address to access the object later on and then call its method. So now when I do that, I could now say P1 dot, I would call the print person method, and I save. Now when we run this code, you realize, let me add something here first. System.out.println before the person data is set. Now when I run this code, you would realize that the value of the age will be 0 and the value of the name will be null, which is the default value for a string and an integer. Why is that? Because here we are printing the name. Inside the print person method, we are printing the name and the age in this sentence. So let me run it and let's see what happens. Then I'll come back and do something else and we'll explain better. You see? Let me just add something here to make it space out more. Okay, you see it starts, right? It prints out the first one. Main method started. Good. It goes down before the person data is set. Now it says null is 0 years old. Why? Because we have created an object in memory, right? We have called the constructor. We have created an object in memory, and the object has the default values. Now, since we have stored the object here, we can now call the print person method on that object to give us the name that was created in memory. If I go back to our slides, you would see that here. This that was created in memory here. We stored it, and now we are calling print person to give us these. But because no values have been passed there, we have the default. So now what I'm going to do is I'm going to create a constructor, public person. Remember, this constructor, the first one I'm going to create, will take 2 arguments, which means we must pass in the arguments when we want to initialize the object, when we want to instantiate the object. So I'll say int ph and string pname, and inside here I would say age is equal to ph and name is equal to pname. Like I said, you can always press Ctrl and Tab for the IDE to give you proposals when you start typing something. Okay, so now I'm going to come here. Good. Just to explain the concept, look at, now I have an error in my code, right? If I try to run this program, well, before that, take a moment, think and tell me if you see where the problem is coming from. Look at my class, and I have an error message here. Good. What's happening? I'm trying to call the default constructor. Remember one of our rules? You cannot have a default constructor. Java does not insert the default constructor for you if you have a constructor that takes in arguments. If I take this out and I save my program, it's fine. I don't have a constructor, but I'm calling a constructor to construct my person. Because I don't have any constructor, Java has inserted the default constructor for me. Now I insert a constructor with arguments. I have an error. Java does not insert the default constructor for me when I already have a constructor. So since I also need a constructor with no arguments, I'm going to say public person. I explicitly create one now and I leave it empty to be able to use it. It's going to construct the object, but aside that, it won't do anything else. Now you realize that the error is gone. Okay, that has been demonstrated. We now know that once you insert a constructor that takes in arguments, you can no longer use the default constructor unless you explicitly create it. So now I would construct a different person using the other constructor. Person, let me print out system.out .print line. You don't have to bother about this on this \n. That's just an escape for a blank line to be printed. If you're coming from C or maybe PHP or C++, you know what that is. So what I'm going to do here is I'll print construction with an argument constructor. All right, that's just a message to show us where we are in our program. And now I would say person p2 is equal to new person, and this time I'm going to pass in age 34 and maybe a string Jonathan. Good. That's it. And now I'm going to print out my person again. I'm going to now call p2 dot print person. Let's see what happens. Good. Our program starts. Main method started. Next message, before the person data is set. Now what happens? After we do that, we call the no arguments constructor, this one that does nothing, and it creates an object for us, but the object will take the default values of these, which is 0 and null for age and name respectively. And that's why we see here null is 0 years old, which means it is this constructor that was created, that was called, this constructor that was called. It does nothing. Later on, when we call in, later on we go down here and we print out another statement, construction with an argument constructor. And here you see the message construction with an argument constructor. And down here we create an object and we pass in the values 34 and Jonathan, and we store a reference to that object